There's those drums that we wait for, Paul, in the intro music before we can start. Hi, good to see you.
Hi, good to see you too.
Happy September, happy post-Labor Day.
Yeah, baby, it's here. How's it feel up there?
And I'll tell you how it feels. 2 days ago, Tuesday, it was 98 degrees.
Wow.
Yesterday, Wednesday, it was 68 degrees. For the high, not for the low.
98?
98 to 68, a 30-degree decrease, after Labor Day. So it's like summer ends, baby, and then we got one extra day, and then that's it. It's like some middle manager came in and shut down the party and said, everybody back to work.
Wow. I knew there was a heat wave across. See, the Southeast is just somehow, I don't know the details, but insulated from this. 98 was the high in Atlanta this year.
The high in Atlanta.
Which is a pretty normal high.
Like the hottest day it was in Atlanta was 98.
We didn't hit triple digits.
Well,
and 98 as a high for the summer is normal here and has been for decades. We've always had a few hot days of the year. Certainly it's higher than average, but it happens really every summer.
Oh, for sure. Yeah. But we had 100-degree days here in the Midwest. In Minneapolis, as in Milwaukee, it was 101 like a week ago.
I mean, here, seriously, living here for the last 15 years, you would not, other than the fact that we haven't had as many super cold days, like 0-degree days, that used to happen here once every couple of years. We'd have a week down in the single digits.
Wow.
But that hasn't really happened. That's the only thing I can point to here in the Southeast that makes me think that something weird's going on.
Today I look out the window, it's going to be cloudy and I don't know, 70, 72. Fall weather's here already.
That sounds really good.
Does that sound lovely?
Yeah.
Hey, for those who don't know, I'm Doug Pagitt in Minneapolis. This is Paul Wallace in, snuggled just outside of Atlanta. For those that don't know the Decatur places of Georgia.
Yeah.
And Paul is an astrophysicist, a professor. So we have to talk about that because you're back to school.
Oh, baby.
Author, pastor, husband, friend, and avid birder. And Paul, last time we talked a few weeks ago, you were saying you were going to go to every county in Georgia and
159 of them.
And see a bird.
Well, no, actually, I'm not just driving through. I'm actually, I got a rule. The rule is I spend at least an hour, like deliberately birding on purpose.
Oh.
But so far, my shortest time's been 2.5 hours. So.
Okay, so you've set up a set of conditions for your what was it? 100 and I know you just said the number 101.
159.
159 counties.
It's crazy.
Well, first of all, why are they dividing Georgia up into so many counties?
Well,
Does it really take this many counties?
Do you know what I think it is? I think it's just the old sort of conservative reactionary kind of like, well, you don't like the way we do it. We don't like the way you do it. We're going to split up. I mean, if you look at the history, it's basically a history of counties getting smaller. I think it's these little arguments of,
more local
county, and then they just split up because they just don't want to deal with each other. It's like local government. I think that's basically it.
Maybe that's where law. Maybe that's where congressional representative from Georgia, Marjorie Taylor Greene, suggests that we should have a national divorce and separate the country into two different groups. Exactly. Which is what we had. It was called a civil war, and then we decided not to go down that path.
Wow, can you hear that?
Yeah, what you got going on over there? You got garbage disposal that just...
No, I got my window open because it's kind of nice today, and the guys coming around with the... Let me go.
With the weed whacker.
Yeah,
guys coming around. Well, hey, I'll just mention that Mike here on the live stream over on our YouTube channel, our preferred place for anybody watching this later, by the way.
I
says good morning, Paul and Doug, and yes, we're back and we're on schedule. Thank you for noticing. Mike, that sometimes we start Thursdays at, what I call 8 a.m. Paul calls 9 a.m. Mike, I believe where you live, you might call 6 a.m. And there's even some people in the middle of this country who call it 7 a.m. Turns out 14 hours ahead of here in Japan, they would call it 10 p.m. And I only know that, Paul, because I looked up some stories about the moon and saw Japan and found out what time it was in Japan when I had to I have to say it very quietly. I had to ask Siri what
what time it was in
what
Japan?
time it was in Japan. Yep. Well, I think there might only be one time zone, but I don't know that. I
I
should have said.
suspect there is only one in Japan.
Yeah, yeah, I would think so.
It-
Now, if that were Georgia, they would divide that sucker up into 11, 12 different time
11
zones,
or 12 different time
just for
zones, right?
the point of it.
Right.
All right, hey, we're going to talk about that. We're going to talk about the moon and sky and what it means to be common gooders here on Earth. But how's school going? As a professor, are you fully back in now? All the students have moved
Yeah,
onto campus, and
I'm fully back in, and it's extra deep this year because I'm the chair of the department this time.
oh my goodness,
Yeah,
the
yeah,
chairman
believe me.
too.
Yeah, it's a service opportunity. Let's put it that way. So I'm doing that for the first time, and I'm going up for a promotion, which is all my stuff is due next week. And it's a big pile of stuff I put together for that. And we're hiring somebody in the
Boy,
department.
what more accomplishments can one person rack up in life, Paul? It's unbelievable. I mean, yeah, Chairman, you got that fancy new office that we looked at. You literally have an observatory like above your head, right?
Yeah,
Isn't there?
yeah,
Isn't it right above
yeah.
you?
It's right up there. Yeah.
And with that fancy office and observatory, did you have to become the chair? Was that like part of the deal?
No,
Did they
it's
tell
because
you?
we have a retirement in the department, basically.
Mm.
And Amy had been chair, and might I say, she did a fantastic job. And but now she's leaving, and I'm the senior person now. I've been here for 12 years.
Okay.
And I'm the senior person. So I didn't go seeking this particular glory.
Yeah,
Let's put
I
it that
gotcha.
way.
I gotcha. You just have to do it.
But I just have to do it.
They're like, Paul, you have shirked this responsibility
Yeah.
for, the better part
Yeah,
of a decade.
This is not like the president of the United States where people line up, eager to, take the reins of power. Believe me, it's truly, it really is in a small department like this. To be completely honest, it really is just a service.
Yeah.
It's just a service thing. The word chair makes everybody think that I have some sort of
Yeah, it does. That's why we
like
use it.
as if people stand up when I walk in the room or something. It's not like that.
Well, I
But
will.
I'm happy to do it, but it's just a pretty steep learning curve. So
Now,
I feel like I've got all this administrative stuff to do, and occasionally I get to teach students.
Hey, how's the vibe with those students? Now, we're now into a full school year back in session since COVID stuff. So, like, there was a COVID year or two of new incoming college students.
Yeah.
How are these? Are they more educated now than they were a couple of years ago when they had to sit at home and watch Zoom meetings?
It's interesting because the population of students I teach, I never teach first years.
Okay.
Never. And I very rarely teach sophomores.
Wow.
I teach sort of an odd group of students, non-traditional students who are most really adults, age 22 and up. And then I teach physics majors who are, and the courses I teach are sort of junior, senior level courses. So I don't really have a sense of what this new class is like because I never get exposed to them.
Okay. Do you even smile at them, acknowledge them when you're walking by them on campus? Or do you just look right through them like a Bruce Springsteen lyric?
No, you sort of notice them because they're either you sort of know who they are, and I try to be nice to them. Dining hall is when I see most of them because I eat in a dining hall. They have this really great subsidized lunch deal for faculty in the dining halls. $3 for lunch every day. So
you have to tolerate freshmen at least to get a value lunch.
That's right. Yeah.
as chairman of departments would only do, they would only be
and they don't call them freshmen here.
First years?
It's women's college. They call them first years. Yeah.
Wow. Yeah, there is a gender word in there, isn't there?
Yeah, freshman. Yeah, I think they just made it simple and just decided to call them first years.
Huh. What else do they do around there? Because it's a all women's college.
Well, there's no football. It's really kind of a nerdy school. I mean, we have athletics. It's NCAA Division III.
Yeah.
but it's really not emphasized. I mean, mostly the students who play on the teams are just students who loved playing in high school and wanted to keep playing.
Sure.
You
Yeah.
know, they were standouts in high school and wanted to keep playing, but weren't going to go on to any.
What's the
higher level.
mascot? What's the mascot there of St. Agnes?
Well, it's Agnes Scott College.
Agnes Scott. I know. I do
You
call it
always
St.
call it
Agnes
St.
all the
Agnes.
time. I know. It's
okay.
unbelievable. It's unbelievable.
So
if you wouldn't mind changing the name, that would really make it easier on a few of us.
So we call it Agnes. That's what we call it. Like, I'm going to Agnes. Welcome to Agnes. It goes by the first name. That's sort of the colloquial way of referring to it. But it's Agnes Scott, so it's the Scotties.
Oh, the Scotties.
Yeah.
Little dog?
Little dog.
Like a handkerchief around the neck? The whole thing?
Exactly. You got it. Very threatening.
Hey, Paul, talking about the sky and talking about mascots is just the perfect setup for this fantastic little story. And you and I are big fans of headlines, and this one just had me giggling because it says, asteroid the size of 81 bulldogs to pass Earth on Wednesday. That was yesterday. An 81 bulldog-sized asteroid passed the Earth.
You know, what was the last one we had?
It was camels.
Like camels?
It was yeah.
With the camels one, it was like the size of the length of so many camels.
Yes.
I felt like somebody was just kind of getting punchy one day, but now I think somebody's doing this on purpose.
Well, I'm beginning to think, because remember when the camels, I'm sliding this image down now for people that are watching this online.
Yeah.
There was something to do with Jerusalem or the Middle East or something as to why they used camels as a size reference.
Well, there
and
you
this
go.
little story comes from the Jerusalem Post, which I sure hope we all subscribe to. From the Jerusalem Post, that they're going to compare the size of an asteroid to bulldogs.
Well, and was the last one from the Jerusalem Post also?
There was something about that whole situation of measurement and what animals are used. We would use horses for a lot of things, and there was something about it being somehow we got to the bottom of it. I don't remember the details. Maybe Mike does. Is one of the frequent viewers of this episode. Maybe it has something to do with that. But it sort of reminded me when I saw this in the Jerusalem Post. But it has a reference to Georgia Bulldogs, and not the mascot of Georgia. So maybe it was something to do with Georgia. But it caught me a giggle, I'll tell you that.
Of course. I think that's part of the
81 Bulldogs.
I mean, that's not really all that big. You could easily fit 81 Bulldogs in my office here with lots of space to, an average-sized room, right? You could put a lot of 81 Bulldogs with a lot of room to spare.
It seems like big for a rock flying through the Earth, but I guess asteroid size, if that hits a city, that's going to cause a little bit of, or are you thinking it's small enough it would just break up? Our atmosphere's tough enough.
It would mostly break up. Something that size would mostly break up, and you'd have small rocks hit the Earth. And those little small rocks are moving fast enough to do some damage. But I think something of that size would mostly break up.
Well, it does encourage me to recommit to using massive numbers of animals as size references for things.
Not 80 bulldogs.
Yeah, 81.
81
average bulldogs. Average size bulldogs.
They're going with the standard issue bulldog, I think, here.
I'm thinking, yeah, I don't think they're going for the mini bulls or whatever they call them. What are the little bulldogs called? Well, look, science people, space people especially, space people, always have to come up with something that helps people connect to the story of the sky, right?
That's right. I mean, it's so remote and sort of it doesn't connect with everyday life. Yeah,
right. It's bleak like the human heart up there, and just dark and profoundly empty.
I'm gonna have to remember that.
Full of
bleak like the human heart.
Yeah, you start that with those advanced students saying things like, thanks for being here, and glad we're going to study something as bleak as the human heart. That is space.
Welcoming.
The absence of all things. All right. So one of our frequent listeners, Brandon, sent this message to me, and it's an article from the New York Times, an opinion piece, granted, but from the New York Times, that says the story of our universe may be starting to unravel. And then Brandon writes, Dang, the Big Bang was wrong, maybe, sorta. And then he asked this question. I could only get through half of this article, but it sounds interesting. Has the Vote Common Good astrophysicist talked about that yet? Now, he treats you like a freshman where he doesn't even use your name. Like a freshman at Agnes Scott.
I was kind of happy to be referred to as the VCG. I was actually kind of pleased with that reference.
Yeah, well, as you are, yes. It's just another one of your great accomplishments
I'll
and
put it on
monikers.
my CV when I go up for this promotion. I'll say,
please do. Because, look, if we need to match that promotion to keep you here, we will match that promotion. You just let me know what promotion you need. And it's like that episode of Cheers where you get to pick your own title, Paul. You can be anything you want around here.
All right.
All right. So here's what he's getting at. And this has been some news. There was another news story about this saying we're overplaying what we don't know about, space. It's being overplayed. But I just want to recount it again for the avid listeners like Brandon and others who are begging to know what the Vote Common Good astrophysicist thinks about this. And that is our basic understanding of how the cosmos came into being called into question because some of the new data that's coming from the Webb telescope is telling us things that don't match the standard model for the Big Bang. So let us know again, Paul. How have we been lied to?
That's right. It's all a put on. Somewhere somebody's laughing. So I have not actually read this story in detail, but I suspect I know what's behind it. And that is that some data that's coming from the Webb telescope challenges some aspects of our standard Big Bang theory. Okay. That's kind of what astronomers actually kind of dream of, is this kind of thing. We like it when our ideas get challenged because that means that there's something new going on that we get to go figure out. It's like a whole new puzzle to solve, right? So people are not, believe me, at this point in despair that our beloved theory, the Big Bang, is wrong. My suspicion is that the overall sort of broad strokes of the Big Bang are going to be with us for centuries. That it's not going to go away. The overall, but some of the details of it may be challenged. And I think in this case, I believe it's still connected to those observations of galaxies forming very early in the history of the universe. Is that right?
Yeah, that's look. And this is a New York Times particular piece. This articles are roaming around lots of different websites. I went, clicked on the link, went to the New York Times, and then it told me that I had to pay them to be there. But then made an offer you can't refuse, like a New York.
One of those offers.
Like a failed casino owner, New York real estate magnate would call Ukraine president and say, "You need to do us a favor first." And they said $4 for 4 months. Or $4 for each of 4 months, or something. Anyway, for $4, I get four months worth of the New York Times.
Did you bite?
I did. Yeah. For $4. Yeah, I literally did the thing people do when they're like making a calculation. How many bulldogs could you feed with $4? you know that kind of thing where you're like, what is $4 equivalent to? At least I do that in my brain a lot about this kind of stuff. Yeah. I thought, okay, it's worth it to get a few articles. And I'm tired of people sending me articles that are great. And then I click on them. And then the New York Times tells me, hold up a second, fella. You can't just read these.
Believe me, I know the feeling. And I thought our college had a institutional subscription.
Oh, probably.
Anybody coming from one of the, addresses here would get in. But that's not true.
It's not true.
Well, there may be a password. I don't know, but
well, as the chairman of a department, I think someone knows how to get to the bottom of this little endeavor. So I read the article, and one of the pieces of it is this thing where it says, "Look, what we used to think about the order in which things processed from the bang." With the information we now have, and here's a nice illustration they used, it would be like seeing a picture of a grandparent with a grandchild, but the grandparent is the child's age. So they're kind of saying like things are not happening. Like we needed more time for that thing to have produced that thing.
Right. That's a nice analogy. Yeah, I like that.
Yeah.
So these galaxies shouldn't have existed that early.
Yes.
Is basically the point. And so the article a few weeks ago was suggesting that maybe the universe is like maybe twice as old as we thought, or something like that.
Something like that. Yeah. Yeah.
So, which I still can't quite see how that fits in with other things, but so what's happening here is the Big Bang wouldn't be wrong so much as maybe incomplete.
Okay, that's the timing on it. But I mean, this is a good point. A lot of us were instructed in school. Look, here's how it happened, right? And that's it, you know. And then you went over to the other class where they told you how to make a table in wood shop, and you went to history and they told you how it happened, and you went to health class and they told you how babies are made, and all those things are just like what you're getting in junior high, you know. This whole mix-up.
Just the way the world is.
And then people start being like, is that really how you make a table? Is that really what happened in history? Is that really how the cosmos got here?
Yeah.
Mike in the chat says he's always had doubts about the Big Bang because it discounts organic renewal in evolution, which I'd be interested. Mike, feel free to write more about that. Love to know what you're getting at there. So he's not discounting it as I discount the Big Bang because the book of Genesis tells me such and such, or my religious tradition taught me this, which a lot of people have a problem with the Big Bang for that reason.
Sure.
But others are like, no, there's stuff we seem to know about change and all that. I don't know. It messes people. So the Big Bang, while it's very common in our parlance, does sit in a funny place for people, doesn't it? Like,
it does, because it's one of these situations where you kind of have to just trust people.
Yeah.
Because you don't know the evidence. It's like when people tell you that the Earth is moving. We've talked about this. I mean, what evidence do you have, Doug Pagitt, or anybody listening, like of your own, that the Earth is in motion? And the answer is you really don't have any. You just trust the people who told you that when you were in 4th grade.
Yes.
And so you kind of have to just believe it. And the truth is when you start looking, for the Earth's motion, the evidence is just absolutely overwhelming. There's this, the alternate theories you'd have to come up with to explain the data that we have are so ridiculous and so contrived.
Yes.
That we just discount them.
That's great.
That's more or less the same case for the Big Bang. But there's more looseness in it, a little bit more. Some of the details are a little bit more difficult to know about. And the truth is that's really true with anything. I like to tell my students that my physics majors, they're not mine, pardon me, our physics majors, the physics majors at Agnes here at the college,
the Scotties,
that learning physics is just kind of a series of learning that what you learned before isn't quite true. It's almost true. And there's a truer, deeper way of looking at things that is not only more accurate, but covers more ground. But you can't just start them with string theory, right? I mean, you got to start with something that they have an intuition about. So this is kind of what it's like for any subject. You mentioned history, right? You read these sentences in your sophomore level history book, and then you start digging into it, and you're like, wow, this is really a lot more going on than what I thought, and it's not quite as clear cut as I thought. The more you look at things, the more interesting they get.
Yeah, and I guess you do, as you said, you don't always have proof. You have a series of people you trust.
You don't have proof yourself, right?
Yes. Like when my mom said she loved me, and then I said, well, there's no proof. And then she said, well, it's just have to believe people that tell you things, like that. It's not true.
Exactly like that.
That's not true. My mom was very, very, very much in love with me to a, possessive level. No, that's not true either. So Carolyn on Facebook says, well, isn't that basically why we call it a theory as opposed to something else. But I don't think that's right. I don't think it's
Right.
like something gets theory category if we're unsure. Can you, in
Yeah,
science,
this is
especially in
one of
your fields of science, can you talk a bit about
this
how
is
that
one
word
of
gets
those
used?
this is one of those places where the way words are used by scientists is different than the way it's used by the non-scientists. Um, there's all kinds of examples of this in physics alone, where we
Okay.
use words in a certain way that mean certain things that don't the non-physicist would use the same word and mean something different. And that's probably true for any field, but theory in science is the highest level of certainty that we have.
Well, look at this. I've never heard this little inverted
Yeah,
pyramid you've got. All right.
yeah. So a theory is like, putting a crown on an idea. It's like, this is a great, solid idea. This is not something
Hmm.
that we've just it's not speculation. It doesn't mean speculation. It means this is the most it's sort of the highest status of
How do you like that?
of
What's just below that? What's sort of the freshman level of of that you wouldn't need to spend your time with?
um,
Like a
yeah,
hypothesis,
conjecture.
conjecture,
That's a
hypothesis.
term. That's a term for mathematics, for something
Okay.
that seems highly probable but has not been proven. As a conjecture is a good word.
So when
Uh,
people are talking about ideas or they've got a hypothesis about something or they want to test something, they're they're not in science. They're not calling that a theory. They're not like, hey, I got a theory for this.
right,
You're saying no, they hold off on that until they have enough structure and
right,
evidence and
right,
argument that it reaches the level of a theory. Where in
right.
popular language, we're like, I'm not sure what happened, but I got a theory about
Exactly. It's
this.
not that way.
It's the
We don't
opposite.
we don't call it a theory until
Huh.
until
Well,
it's
how do you
been
like them
it's
apples?
been supported. Yeah, that's a really important distinction. So when we say we say the theory of evolution, the Big Bang theory, in the same way that we would say the theory of gravity. You
Yeah,
know,
things that aren't true or that we just
Einstein's
keep saying to each other to control the minds of the weak.
or Newton's theory of gravity, which is obviously something that we all experience every day, and which is very simple, relatively
Huh.
straightforward because we all have an experience of it. Uh, the theory Newtonian gravity and the theory of Big Bang. I mean, they're both at the same
Okay. Ah,
level.
well, very helpful. Well, Carolyn, thank you for your comment there. That was helpful for me at least to get a little clarity on that one. All right, hey Paul, let's shift gears here for a second. I shared with you this headline: "The moon is drifting away from the Earth and making days longer." New study finds. There was another article about this same thing that said the Earth is moving away, or the moon is moving away from the Earth, and we're starting to see the impacts or something like real clickbait kind of
Wow,
thing.
really? That is clickbait. Yeah,
Yeah, it was
because
great. And then I read it, and it was the same, basically the same story as this
right.
under a different headline. And the argument here is that the Earth is slowing in its rotation because of the impact of the moon, which I know you've walked me through this a lot, but I got to tell you, it still really wigs me out, that little bitty thing compared to our, and like, that the little speck out there is bossing around the spin of the Earth.
Yep, and
So
has
just
been for hundreds of millions of years.
So just, when you share this theory with me, just be gentle again. But apparently it's moving away. And so things are getting slower by like 200,000, like every 200,000 years, there's a few seconds or minute. But
Yeah,
they think that back early days on the Earth were 18 hours when the moon
yeah,
was closer.
absolutely. Yeah, we have really good evidence of that.
But some reason this has reached news status literally
Yeah,
this morning
I'm not
in
sure
my news feed.
why this is making because I haven't read the article. I don't know why it's making. Here's what I can tell you: the discovery that the moon is drifting away is not new, and that the
Okay.
days are getting longer. That is not new.
Okay.
There might be something new about that's been discovered, but the very fact of the Earth slowing down its rotation has been known for a long time, and it's been known that the moon is responsible for it.
And we've been talking about that on the radio show previous to this podcast. We've been talking about that for a long time. So my theory is that some editor at some science journal watches the podcast and listens to it and was like, "Hey, did you know that the Earth is slowing in its rotation?" That's why it's just we're just in a circle. They heard you talking about it. Okay, but it is fascinating to people because one of the things that feels like it's settled is how many days there are in a year, how many hours there are in a day, how many minutes there are in an hour, how many seconds there are, how many nanoseconds. That feels like math to people, and we really want our math to be settled, right? So it's like that's one of the givens. So I think what taps into someone as an article is, what? Oh, come on. I mean,
it is settled, but it's settled on a lot larger scale than we're used to thinking about it. It's because what I'm trying to say is that the length of the day is changing, but we know how fast it's changing.
Okay.
In other words, it's not like, but yes, your point is that all of a sudden things are not as they seem, that the days are not constant length anymore. And that's true. About 100 years ago, here's the rate. The rate is about 1 millisecond per day. The days get longer by 1 millisecond every century.
1 second every century, because one millisecond.
One millisecond, the days become, so what's today? September 7th, 1923 was 1 millisecond longer than today.
Oh. Well, you use these woke terms like milliseconds.
Shorter than today, but the change,
Yeah, shorter. Today's a little longer. We have a millisecond more than your great grandparents had. Right. So spend that time wisely. Exactly. I was going to make a joke about you using the metric system in milliseconds as sort of a sign of your wokeness, and I just couldn't listen to it. Your European scientific freedom-hating language anymore. So 1 millisecond, which is not very much, but I guess over 1 billion years, 3 billion years, 4 billion, it's like real money. A penny saved is a penny earned. It's going to all add up someday. Yeah, that's. Okay, just walk us through again then. How, in the name of all things spinning, what does the moon have to do with how fast the Earth is rotating?
Has to do with the tides. It has to do with the tides.
Oh, good Lord. Okay, the tides. All right.
Yeah.
Hey, remember when Bill O'Reilly said the tides, they come in, they go out. How, we don't even know how. And people were like,
I do remember that. I remember thinking,
oh no, we know how.
I think we know. I think we know how that happens. So if you could look at the Earth from like above the North Pole, you would see
it's flat.
It would look round, right? Because you're looking right down at the, but it would actually wouldn't be quite round. It'd be bulged a little bit.
Okay.
A little bit, because the water is deeper.
Yeah. In the like the hips on a 57-year-old man running a podcast. Yeah. Yep. I know what you're saying.
And basically, I could show you the math, but I'm trying to simplify this as much as possible.
Please.
The moon basically puts a torque on the Earth. You know what a torque is? It's something that creates a twist, okay? Mm-hmm. And it puts a torque on the Earth because of that bulge in the tides. The tides interacting with the moon.
The water in the oceans,
yes,
is sloshing around, and that's what's making the Earth spin?
No, that's what's making the Earth slow down. Basically, put it this way: here's the simplest way to put it: the tidal bulges create friction. Produce friction and slow the Earth's rotation down.
Okay, what's causing the Earth to spin in the first place? If the moon's effect on the tides and the water is creating friction to slow it down,
what caused the Earth to rotate in the first place?
Mm-hmm. I don't know if that's a laugh of that's the question of a freshman or that's a bedazzling question. I'm not sure.
Let's table that for a minute, because that's going to get us down a whole different. But let me just say that all the planets are rotating All the galaxies are
Yeah.
rotating. The sun's rotating.
Everything's rotating.
Everything's rotating. Okay.
Yes.
And the Earth is just along for the same ride as everything else. But that's a whole
Okay.
different question. But the point is that the moon is applying a torque to the Earth and slowing it down. Basically, it's friction between the tidal bulges and the Earth.
So the speed of
What's
everything
happening is
that's
this. Yeah.
okay. You finished that.
When you're at the beach and you're
Yes.
there for a few days and you see the tides come in and out.
Mm-hmm. And not the waves. Now, we're not talking about the waves. You're talking about the level at which
I'm talking about
how high up on the sand the water goes.
You go out in the morning and the beach is very narrow because the water's high up on the beach. And then you go out in the afternoon and the beach is very wide because the water's been drawn out.
Okay.
Okay. When the water is high, what has happened is the tidal bulges on the Earth remain more or less fixed and the Earth rotates under them. You are rotating through the tidal bulges when that happens. They're not coming to you. You're coming to them. You on the beach are actually moving through the deep water and then through the shallow water as the Earth rotates underneath you.
The Earth is sitting still? Are the water sitting still in the...
Approximately. Think of it as
the
water, the deep parts of the ocean and the shallow parts are staying still, and the Earth is rotating you through those bulges, through those deep parts and shallow parts. That creates a friction on the Earth's rotation. It's got to rotate itself, push through those deep parts and those shallow parts alternatively, and that slows the rotation down. That's the simplest way I can put it.
Okay. That's a great answer. And that is blowing my mind that the water is not moving. The land is moving.
Right. The land is moving and the deep parts of the water are staying still on the shallow parts.
I just realized I don't know anything. I would love to see comments from people who are like, yeah, Doug, everyone knows that's how that works.
No, most people don't know that.
All right. So things like Mars, other planets that are spinning that don't have water in liquid form, they're rotating at the same speed. Nothing's slowing them down. There's no friction.
If there is friction with them, it is far less. It is far less then. And Mars, not really, because there's no moon strong enough to really affect its.
Okay.
It's because what happens with the with the water happens a little bit with the Earth as well. The motion of the presence of the moon actually distorts the shape of the Earth itself a little bit too.
So when the moon is closer to the Earth, it was 1 billion years ago, 2 billion years ago, no, 1.5 billion years. How long has the moon been around? How old is the moon?
Just slightly shorter time than the Earth. So approximately the same.
Which is
4.3 billion.
4.3 is the new number. Okay. So 1 billion years ago.
The new number.
Oh, I know that doesn't know, people would. Yeah. So 1 billion years ago, the moon was closer.
Yeah.
And the tides were
greater.
All greater. And
they were more
but
extreme.
Also the land masses were different, like everything, Platonic shifts and I mean the lands, everything. 1 billion years ago, some land was underwater, like it was a totally different story.
Right.
So calculating that must be tough because
and the further back in time you go with the continental, drift, the plate tectonics, the less certain we are.
Wow.
Another aspect of this I wanted to mention is that you actually mentioned there is that the moon, as this happens, the moon is actually drifting further away.
Why is that happening?
Because the same torque is slowing it down in its orbit.
Oh.
And as it slows down, it drifts.
What's slowing it down? It doesn't have those big tidal.
It's the same. It's the same. It's the same, basically, tidal bulge of the Earth that provides a torque on it.
We're torquing each other.
We're torquing each other. Exactly. And so it's drifting away at about 2 centimeters per year.
Okay, 2 centimeters.
Yep, which is about as fast as your fingernails grow.
Is that why, and we're going to have a little story about other nations other than the United States sending rockets to the moon. Russia just tried to send one and it crashed. They had the wrong coordinates or something. I'm not sure how that happens. But does that have anything to do with what we know or don't know about the moon or landing
No,
rockets there? Or
no, because the
okay,
drift is
it's not
so
enough.
slow. When the Apollo astronauts landed up there on the moon, they put these little reflecting mirrors up there, and we can bounce light off of these things and get the distance to the moon like to within the fraction of a centimeter. I mean, to these plates at least.
Huh.
And so, we suspected it was happening already. We had evidence on Earth that the day's length were changing and the moon was drifting away, but that confirmed it.
And those mirrors are still there? Are they still reading those mirrors? Wow.
Oh yeah, yeah.
Boy, those things last.
There's no wind or erosion or anything like that up there. So they're perfectly as good as they were when they dropped them down there.
Huh. Pretty great. All right. Hey, a couple more things about the moon. Japan, 12, 14 hours ago, something like that, launched a new rocket to the moon and to unleash a X-ray satellite.
Yep.
To pay attention to things happening. Japan is big into this. And as it turns out, that's not right. And as it turns out, Indonesia, I'm trying to get the right.
You'll get it.
Trying to get my right picture. And Indonesia has launched a rocket to the moon and a mission to study the sun. Like they're going to go sit between the Earth and the sun someplace in some quadrant up there and study it. I didn't know the name of it. Named after an Italian sky observer, I'm sure.
Yeah.
But I think it's pretty great that India and Japan are really taking the lead on these endeavors.
Yeah.
Does it seem that way to you as well?
Yeah, it's really something. They're joining the club with us and Russia and China and
and like Indonesia dropped one on the south side of the moon or something, and like they're seeing things that other people aren't. And they picked up not an earthquake. They picked up movement, a shake,
a moonquake.
Was it from our torque? Did we over torque them and cause a?
No, that'd be cool, but
a torque quake. No, that's not a thing.
Apparently they did. I saw that they had picked up a little bit of seismic activity on the moon.
Yeah, and apparently they were pretty excited about it. Like, hey, we've picked up something that other people haven't seen before.
Well, landing, in a different location like the South Pole, you learn you open yourself up to learning all kinds of new things.
Yeah,
because that's hardly been explored at all down there.
Yeah. Did I say Indonesia?
I did
not mean. Thank you, Bob, and thank you for not correcting me in front of the kids, Paul. I appreciate that. India, not Indonesia. India accomplishes. Not that Indonesia, couldn't if they set their minds to it. I'm quite sure.
Do you know what I read this
week? Hadn't done it.
I read that India might change its name. Did you see that?
No.
Yes. There's some bill has come up. And it looks like it might actually pass. They might actually change the name of India.
Okay.
Can you imagine? I can't remember.
Oh.
Bhutan?
Oh.
Something. I can't remember.
Okay.
But it's going to be completely earth-shattering, and it's going to take 100 years for that to...
to take a while.
For people to change. Like a whole generation needs to be born,
Huh. Yabitz is saying that it might have to do with Hindu nationalist leadership in India.
Oh,
which might be maybe there's an identity thing that they're trying to get to. And this is a big month for stargazers and for moon watchers. This is a big moon month. There's like blue moons and special moons and harvest moons and an eclipse.
An eclipse coming up next month. Yep.
By the way, we should remind these good people watching, because if anybody's paying attention to this at this point, they're key for joining us.
This is our core audience here.
Next April in Texas, because there's going to be a solar eclipse that is, as Paul partially experienced or did experience
I did.
year ago or so.
2017.
And these are meant to be sort of once in a lifetime experiences, but you live long enough and you might get two. We're going to go to, Paul and I and a whole gaggle are going to go to the places in Texas where we should watch this solar eclipse, April 4th or 14th.
Awesome. 8th. I can't remember. Something like that.
So be on our Vote Common Good email list. Go to votecommongood.com. Be sure you get on the email list because we're going to be sending out information about all that. We'll say it on here too, but you just never know. Well, this is going to go.
It's going to be awesome.
Yeah, we're gonna go watch that eclipse. But in the meantime, you can pick up a lunar eclipse over the month of September. It's a big month for watching the moon.
Yep, it is big. Yeah, we had the blue moon in August.
Mm-hmm.
Now we're going to have a lunar eclipse, and then we're going to have a solar eclipse next month. Not total, but.
She just stole my joke. I was going to say, and then we're going to have a total eclipse of the heart, and it's just really going to be.
Oh.
And there's no doubt that we're going to be playing that song in the road trip that takes us to the deserts outside of San Antonio, Texas, to watch that solar eclipse. So come with us, people. We'd love to see, because it's going to be transformative.
And you've never seen one, is that correct, Doug?
No.
I can't wait to watch you. I'm going to be watching you as much. I'm going to be watching the.
Really? Okay.
Oh God, yeah. You're
going to be puppy dog in that thing.
Yeah,
just panting and bouncing around, staring at the sky.
I don't want to, gas it up too much. Just let you just experience it.
Thank you. All right, hey Paul. We know you have a lot to do. You're back in classes. Are you teaching the students today?
I'm teaching this afternoon.
What's on the docket? What's on the syllabus lecture? Do you even know, or do you just pull out a folder out of the folder file?
No, I know. This is a class I really got to prepare for. It's conservation of energy.
Okay. You have to prepare for it because you got real sharp students, and they're not going to tolerate your, not being on your sharpest game.
Well, I tell you, the thing is that I have to prepare for it. One reason, it's an upper level course. I only teach it once every 2 years. But also because I don't want there to be any question in my mind about the material. I can't. The material has to be completely transparent to me in order to teach it, because teaching is not about me knowing the material. It's about me communicating it, which is a different level. You know what I mean? So totally. I need to have it like totally cold in order to teach it effectively.
Yeah, you can't be saying things like, "Well, some people say this, some people say that." You're not. Isn't it? It's not. Yeah.
No, it's not to say that I understand all of it, but I need to have it in my pocket as much as I can.
Are you going to have to brief up on conservation of energy before the afternoon session, or you feel
yeah, I'm going to have to run through a little bit of math, because the way we're doing it is if I was teaching this to like 100 level students, like 100 level class, I wouldn't need to brush up on it. But at the higher levels, it brings in more, and it's a little more subtle. So I need to brush up on it. I don't just have it. I just don't walk around with this in my head all the time.
Are you gonna write it like on a blackboard or a whiteboard?
Oh, yeah, whiteboard.
Take a picture of that and send it, would you? I'd love to. Yeah. We could share that with people. I mean, that kind of stuff.
Yeah.
Because I saw Oppenheimer. I know how this works. I know when people write. I know when people write on the boards.
I do teach one class with an actual slate board and chalk, and that's my preference. I love it. I got this nice set of colored chalk, and
yeah, for sure. Yeah, we got the sound. It's tactile, all that stuff. It's not clean and smooth and.
Right. I make a mess on all over my clothes. It's great.
Yeah. Your hair's all wild at the end of it.
Exactly. Yeah.
You're just yelling, "Who knows?" at the end, and chalk on your fingers. I want to see that. Send a picture of that too, if that were to happen. All right. Well, thanks, Paul, for being part of this today. Sorry for all the weeks of me not having Thursdays available.
Oh, it's all right.
Appreciate that. Thanks, Jim and Yabbits, Kimberly, Bob, Jody or Jordal, Carolyn, Mike, all of you that were willing to write your words here. We appreciate that a lot. And this comes in an audio version and, of course, these video versions. If you're watching on Facebook, want to share with a friend that's not on Facebook, we do this on YouTube. It goes on YouTube, so you can share from there. All right, Paul, thanks.
Sure. Thanks a lot, Doug. Bye.